Hi guys, this is Mrs. Allison. You should have the note sheet Simplifying Rational Expressions in front of you. And we are going to go through that note sheet and just look at what it means to simplify rational expressions. Okay, so first, we should probably define what a rational expression is. So, a rational expression is an algebraic expression that can be written as okay, before I get into what that actually is, let's look at the root word of rational. And what do you notice about the root word of rational? Well, it has the word ratio in it. And what ways can we express a ratio? Right, we can express the ratio as a fraction. So a rational expression is an expression that can be written as a fraction. Now, in rational expressions, that word ratio, the numerator and the denominator need to be polynomials. Okay, so do you remember talking about polynomials? We did it at the very beginning of this semester. What is a polynomial? Well, we know the root word of polynomial means many. And remember, we looked at that term monomial. So anything could be a monomial. X plus 5, 2x minus 3, x squared plus 3x plus 7 are all examples of polynomials. So let's look at some examples of what a rational expression might look like. Okay, we could have something as simple as 5 over x minus 1. This would be a rational expression. We could have something maybe even more complex than that would be 5x over x minus 1. That is also a rational expression. We could have something even more complex that is something like 5x squared plus 3x minus 7 over x squared minus 4. This is also a rational expression. So you will notice that in each numerator and denominator, it's made up of a polynomial. Polynomials. Okay? That's what a rational expression is. Now, as a reminder, what do we know about the denominators of a fraction? There's one thing that a denominator cannot be. It cannot be no matter what we put in it. It just can't be. So what is it? What is it that a fraction in the denominator cannot be? It cannot be 0. This becomes very important, this fact that it can't be 0, because this leads us to our idea of excluded values. Okay? Excluded values of a variable, excluded values are values of a variable that result in a denominator. Let's see if I can fit it all in here. Denominator, of 0. Okay? And they must be excluded from the possible x values, also called the domain. So, excluded values are values of a variable that result in the denominator of 0. And they have to be excluded from the x values. So let me show you how we're going to do excluded values. Let's look at this first example. We have 5 over x minus 4. Okay? To state the excluded values of each rational expression, notice it's an expression, there's no equal sign at the moment. This rational expression, to state the excluded values, what we're going to do is we are going to actually take the denominator and say that whatever we get, it can't be 0, because this will help us find our excluded values. So if x minus 4 can't be 0, how do I undo this? Well, I'm going to add 4 to both sides. And so that we get x cannot be 4. This is my excluded value. X cannot be 4. So try the next one. Pause the video and take a second and try it. Okay, so hopefully you've paused the video and hopefully you went through and said, okay, that means x plus 7 cannot be 0, which when we take away 7 from both sides, we get x cannot be negative 7. How'd you do? Good. Okay, well, let's make it a little more fun. Let's say my rational expression is x plus 1 over 3x plus 1. If I want to find the excluded values, I'm going to go through and I'm going to set this equal to or not equal to 0. So 3x plus 1 cannot be 0. So I'd need to subtract 1 to get 3x cannot be negative 1. Am I done though? I don't have what x can't be. I have what 3x can't be. So I need to keep solving this and divide by 3. And so we get that x cannot be negative 1/3. That's my excluded value. Okay, well, what about this next one that is really fun? What about the polynomial 3 over x squared plus 3x plus 2? If I know the denominator cannot be 0, and just to save room, I'm just going to write this here. I know this denominator can't be 0. How am I going to figure out what x is? Hopefully your mind goes back to our quadratic unit. Hopefully you notice that this is an x squared and an x, which means and it's equal to 0, which means I need to factor this. And we need to go through our good factoring techniques. So, does it have a greatest common factor? No. Is it a trinomial where a is equal to 1? Yes. So since that, it makes it pretty easy. We can either use Xbox or we can just remember that to factor this, I'm looking for two numbers that multiply to 2, that add to 3, and those two numbers are positive 2, so x plus 2, x plus 1, and those can't be equal to 0. Okay, so what property allows me to now solve this? Right, the zero product property. So we get x plus 2 cannot equal 0, and x plus 1 cannot equal 0. Oops, ran out of room there. And so I'm going to solve each of these. So I get x cannot equal negative 2, and x cannot equal negative 1. So those are my excluded values. Pretty easy, right? Okay, so let's put that with the idea of rational expressions. Why did I make you review factoring right before we did this last week? Let's look at why. Okay. We are now going to simplify the rational expressions and state excluded values. But let's look at something just to remind you that you've done this before. Maybe not with x's, but we've done this before. When we simplify rational expressions, we do it the exact same way we used to simplify fractions. You know, like 4th grade math, simplify fractions. Yeah, we're doing that again. Okay, so we're looking at the way we can simplify rational expressions the same way we did when we were dealing with fractions. How did we do that? Well, the way that we're going to go about doing that is we are going to eliminate any common factors. Okay, so this word right here, this factors right here, ought to clue you in that we are going to need to factor our problem. Okay, so we need to eliminate any common factors that happen in the numerator and denominator. Let's look at what that looked like way back when, like in 4th grade, when we first started doing fractions. Okay, so let's look at the first example, 9/12. Okay, probably back in the day, and now we probably wouldn't, we would just talk about what its common factors are. But back in the day, what you would have done first is you would have said, okay, each of these has a factor of 3. That means 3 times 3 is 9, and 3 times 4 is 12. You've just factored this problem, although we wouldn't normally call it that. That's not what we called it in 4th grade. Same idea though. And remember, to factor this, or to simplify this, we just need to remove any common factors. So I am going to go ahead and cancel out the 3's that they both have in common. Well, now why can I do that? What is 3 divided by 3? It's 1. So I can cancel that out because 3 divided by 3 is 1. And then I'm not really changing my problem any because I'm multiplying by 1. So the end result of this, the simplified fraction, is 3/4. Remember doing that? It's probably been a while. Okay. Let's look at some other examples, the more algebra-based examples, to see if we can do the exact same thing. Okay, so let's look at this next example right here, the 7a cubed b cubed. Oops, that's supposed to say squared. Okay, we're just going to change this. You're just going to have to ignore that that's supposed to say a squared. Sorry. So if we have 7a squared b cubed over 14a cubed b, I need to find their common factor. Okay, maybe a little bit different, but start the way we've started before. If I look at just the normal numbers, the 7 and the 14, what do they both have in common? Well, right, they both have a 7 in common. So I know that my common factor is going to start with 7. Then we're going to look at the A's, only the A's. I'm ignoring the 7 and the 14, I'm ignoring the B's, and I'm looking at the A's. Okay, the numerator is a squared, the denominator is a cubed. What do they have in common? What is their greatest common factor? Well, their greatest common factor would be a squared. Okay, so now let's look at the B's. Okay, if we look at the B's, I have a B cubed and a B. What is their greatest common factor between the two of them? Right, it's B. So I can pull out a B. Now let's look at what's left. I'm essentially factoring these problems just like we've done. 7a squared b cubed, I have 7a squared b, so the thing I'm missing is a b squared. Meaning if I were to multiply this 7a squared b times b squared, I would get 7a squared b cubed. Okay, let's do the same thing in the denominator. And I'm going to pull out a 7a squared b, and that leaves me with 2. I have 1a and no b, so my denominator is 7a squared b times 2a. Do you guys agree with that step? Or are you feeling good? Okay. Now, is there a common factor in the numerator and the denominator? Yeah. 7a squared b is just 1. Just like 5 divided by 5 is 1. X divided by x is 1. 7a squared b over 7a squared b is just 1. So I can reduce that, and it leaves me with b squared over 2a. Now, notice the directions say simplify and state excluded values. Well, why didn't we do that in that first problem? Why didn't I state any excluded values in this 9 divided by 12? Because let's go back and review what an excluded value is. What is it? It's a number that makes the denominator 0. Is there any way to make 4 0? Nope. So therefore I'm ignoring, I did excluded values on that one. I don't need to do it. But let's go back to this problem. Looking at both of my terms in my denominator before I canceled out my 7a squared b, what could I plug in for a and what could I plug in for b that would make my denominator 0? Right, I could plug in, if I plugged in 0, my denominator would be 0 for a. And if I plugged in b equals 0, my denominator for would become 0 if b is 0. So therefore my excluded values, sometimes we abbreviated excluded values with an EV. So if you ever see that on a worksheet or something, that's what that means. So my excluded values, my EVs for this problem are a cannot be 0 and b cannot be 0. Okay, now I actually think the problems that look like this, that one we just did, can be a little bit more complicated than the problem like this next one, believe it or not. So let's try it. X squared minus 2x minus 15 over x squared minus x minus 12. Do you see any common factors? I don't even see any factors. So what do you think I'm going to need to do first? Right, I need to factor. So let's try it. If I look at this problem, the first thing I should always look for when factoring is a greatest common factor. Okay, do I have a greatest common factor in my numerator? I don't see one. Okay, do I have a greatest common factor in my denominator? I don't see one there either. All right, then let's go to the next thing. Is this a trinomial where a equals 1? And the answer is yes. So let's factor it. I'm going to factor it again. You could use Xbox. You don't have to. I like to look at what two numbers multiply to negative 15, add to negative 2. And if you need a refresher, go back and watch those videos on factoring. So what I know is that multiplies to negative 15 adds to negative 2 would be x minus 5 and x plus 3. because negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So that's my numerator. So let's factor my denominator. If I factor this denominator, I'm looking again for two numbers that multiply to negative 12 that add to negative 1. So what are those? Right, I'm looking at x minus 4 and x plus 3. So remember, to simplify this, I'm looking to eliminate any common factors from the numerator and denominator. Do I have any common factors? Yeah, I do. I have the x plus 3 and the x plus 3, although I need to go back and think about that x plus 3 in just a moment. But when I simplify this, once those go away, once those eliminate or reduce to be 1, my final answer to this problem is x minus 5 over x minus 4. This is my final answer. Now, I need to state my excluded values. And excluded values come when the denominator equals 0. So what two equations can I use, and why do I ask for two? Well, clearly I have an excluded value when x minus 4 equals 0. So the first one I'm going to write is that x minus 4 cannot be 0, which means x cannot be 4. What's my second one? Why do I have two? Remember I told you we were going to go back to the x plus 3's? Here we are. This does count as an excluded value. Even though I have reduced it, even though I've simplified it, it still counts as an excluded value. So we get x plus 3 cannot be 0, which means x cannot be negative 3. So my excluded values are x can't be x can't be 4, and then x can't be negative 3. How do we do? Okay, here's what I'd like you to do. Try this next problem. Try this next one, 3x minus 15, x squared minus 7x plus 10. Pause the video and see if you can do it, and then we'll go through it together. Okay, so hopefully you've had a chance to pause this video, try this problem, and let's look at it. We know that we need to factor, so I'm going to start with my primary method of factoring, which is always going to be greatest common factor. So is there a greatest common factor in the numerator of this problem? Yep, there happens to be a greatest common factor. So I can pull out a 3, and it leaves me with x minus 5. And then in the denominator, do I have a greatest common factor? Nope. So start through the process. Do I have a trinomial where a equals 1? And the answer is yes, in this case. So I am looking for two numbers that multiply to positive 10 and at the same time add to negative 7. So if I'm going to multiply to a positive but add to a negative, probably both my signs are going to be negative. So I'm going to have an x minus something and an x minus something. So what are those two somethings? Well, I need to multiply to 10, add to 7. Well, that means I'm going to multiply by 5 and 2. So negative 5 times negative 2 gives me positive 10, and negative 5 minus 2 gives me negative 7. Okay, now I'm looking for common factors. Well, I happen to have a common factor with my x minus 5's. It is possible to have more than one common factor. So it is possible you may be canceling out more than just the x minus 5, and that's okay. So this one I'm only canceling out the x minus 5, and we get 3 on the top is what's left, and x minus 2 in the denominator, and there's my final answer. So let's talk our excluded values. What cannot be counted as a value of x for this problem? Okay, so let's go back to where my denominator could be equal 0, and it includes the one that was canceled out, or the ones that could be canceled out. So I know x minus 5 cannot equal 0, and I know that x minus 2 cannot be 0. So I get x equals or cannot be 5, and x cannot be 2 as my excluded values. How do you do? Okay, now there is no harm in going back and watching this video again. You may need to watch it a couple times. Maybe I spoke too fast. Maybe it was hard to take notes, and so once the notes are taken, maybe to go back and listen to it again while you just watch your notes and see if that makes a little bit more sense. I will hold office hours later this week so we can answer any questions. But check the assignment that you need to do and get that done. And good luck. I know you can do this. It's just now you got to remember all your factoring again. We will chat soon. Have a good day.